Okay, right, question 5, completing the square. You can see this was from an old C1 paper, so the easiest of the, well, apparently the easiest of the A-level papers. So we've got to complete the square for this. If we've got it just one bracket squared, we are completing the square. So 4x squared minus 8x plus 11. So the way I think of it is I'm going to take this 4 out, because I don't want that there when I complete the square. So if I take that 4 out for a bit, x squared minus 2x, I'll keep the rest as it is, plus 11 on the end. So all I'm going to complete the square for is this bit in the middle. So that's x minus 1 minus 1 squared. That bit there is exactly the same as the bit in the bracket on the line above. It's just written in a nicer way. Mathematicians like this more. So I'm just going to multiply out this 4. So now that gives me 4 lots of the bracket bit, 4 lots of the minus 1, and I've still got that plus 11 on the end. Let's tidy that up. Done. A, B and C, you don't need to state them, but A is 4, B is minus 1, and C is 7. We're actually not going to do you any harm. A, B and C are constants to be found. I probably would state them in the end, just to be on the safe side. Okay, use your answer to part A. Have to use your brain to find the greatest value of this thing here. Okay, so normally when we complete the square, we think, what value do we put in here that makes this a minimum? So because this is a reciprocal, it's upside down, making this thing on the bottom as small as possible actually makes a fraction as big as possible. If you think about it, if you make the number on the bottom of a fraction bigger, it makes it smaller. If you make the number on the bottom of the fraction as small as possible, it makes the fraction bigger. A half is bigger than a tenth. Okay, so we want to make that number on the bottom as small as possible to make this fraction as big as possible. So we are still trying to find the minimum of 4x squared minus 8x plus 29. Use your answer to part A. Part A was virtually the same. The only difference was we had 4x squared plus, 4x squared minus 8x plus 11. We've now got plus 29 on the end. So in all intents and purposes, this bit and that bit are exactly the same. The only difference is this is 18 bigger. Okay, 18 bigger. So this bit on the end, it just needs to be 18 bigger. So it would be 4x squared, 4x minus 1 squared, 7, we need to make that 18 bigger. 18 bigger than 7 is 25. Okay, so the bottom of that fraction looks like this. Okay, and completed the squared form. We know that if we made x equals 1, that would minimize this, because if we made x equals 1, that makes that disappear. Okay, if we made x equals 1, that would give us 4 times 1 minus 1 squared plus 24. That's 0 plus 25. That makes that 25. Remember, it's not 25 because it's in that fraction. It's in this thing. But that becomes 0, so the minimum value, the maximum value, the biggest it can be, is 1 over 25. Okay, cut off the bottom. 1 over 25. We've completed the square for the bit on the bottom, making that as small as possible, make the denominator as small as possible, it makes the fraction as big as possible. We get that 1 over 25. If you think about it, if we make x like a really big number, so if you made x like 100 take away 1 is 99. 99 squared is quite big. 4 lots of 99 is even bigger. 4 lots of 99 plus 25 is still pretty big. 1 divided by whatever it is, 400 or something, is a teeny tiny number. So this is quite big in comparison to that.